Hello everyone, welcome to Engineered. In this video, we will be doing this question. So this question says, a newly established town with a population of 1.2 million is to be supplied with water daily at 45 liters per capita, right? And water has to be stored also for higher demand, keeping at least 1% of total demand. The variation of demand is given as below. Now, if you see here, the population is given as 1.2 million and then demand is according to the given as per for one person, that is 45 liter for one person, right? If it is 40 demand is average demand is if for 45 liter per capita, then it is for one person, right? Now for there is the population of 1.2 million will be multiplying into 1.2 million to get for the 1.2 million people, right? So 1.2 million liter per day, right? MLD. And now 45 into 1.2 is 45 into 1.2 is 54, right? So it is 54 MLD. So now total demand is 54 MLD. Now, if you see here, water consumption in percentage and different time frames are given, 5 to 7, 7 to 12. So we need to find the demand according to these particular time frames. So for this 20, it is 25%. 25% of 25% of what? It is 25% of 54, right? So what is 25% of 54? It will be 0.25 into 54. So it will be 13.5, right? So this is 13.5 ml million liter, and for the 35, 0.35 into 54, it will be 18.9. For the 20%, 0.20 into 54, it will be 10.8, and again 10.8 and 0, right? So these are all are in million liter. Right, so this is for the demand part, right? So here is the reservoir, and here is the, let's say this part is demand and to the consumers, and this part is the supply from the let's say river, right? Now river or tube well or something, right? We can put here to the reservoir. Now the demand part is given in the table, this table, right? We just calculated this for the demand part. Now for the supply part, if you see here, determine analytically the balancing reservoir capacity, assuming pumping to be done at a uniform rate, and the period of pumping is 5 p.m. to 10 a.m. and 5 p.m. to 8 p.m., right? So for the supply period, let's write here 5 to 7, 7 to 12, and 12 to 17, and 17 to 19, and 19 to 5, right? Now for this period, it will be 5, the pumping period is 5 to 10, right? So there is 5 to 7, so there is 2 hours, right? So in this particular time frame, will be supplying the water to the reservoir, right? And for the 7 to 12, we only have to go to 10, right? 7, 8, 9, 10, it will be 8, 9, 10, 3 only, right? 3 hours only, here 2 hours, here 3 hours, and from 12 to 17, there is no pumping period, so 0. And for 17 to 19, 17 means 5, right? 5 p.m. So 5 p.m. to 19, there will be 2 hours, right? 5 to 7, and the here is written as 5 to 8. So we only go to 20, right? Only go to 8 p.m. only. So 19 and 20. So 20 is only 1 hour, right? So we don't go 2, 3, 4, 5, right? Because it is only said that the pumping period is 5 to only 8, right? 8 is 20, right? And here 5 is what? 70. So let's move to the next slide. So here is the table 2, 3, 0, 2, 1. And if you can see this time here, this is the pumping hour in the supply side, right? For the supply side. And according to the consumption, we have the demand, right? Demand is 13.5. Let's write 13.5 and 18.9 and 10.8 and then 10.8 and 0. Now for the supply part, it will be this time into okay. So for the supply part, we have derived the time, but we have not derived the demand per hour. So total time is 2 plus 3, 5, 6, 7, 8, right? 8 hours, right? So now we have the demand of so this demand to be fulfilled, right? 54 mld. So this demand is to fulfill by supplying, right? So for the supply, it will be 54 per hour. We need to find per hour, right? So 54 million liter per hour. 54 per hour, we need to divide by 8, right? Because 80 hours of pumping only, right? So 54 divided by 8 is it will be 6.75 million liter per hour. So this is for the supply. This is for the supply, and this is the time. This is the supply. Now let's multiply. So 6.75 into, this is supply for the supply, 6.75 into what? Time, right? So 6.75 into 2, 6.75 into 2, the first one is 13.5, right? And for the second one, it will be 6.575 into 3, right? So it will be 20.25. And the third one, it will be 0, right? Because there is no pumping in this particular time frame. And for the 17 to 19, it will be only 2 hours. So same, 13.5. And for this particular place, it will be only 6.575 into 1, that will be 6.75. Now let's calculate surplus. Surplus is when supply is greater than demand, and deficit is when demand is greater than supply, right? So for the surplus, let's from the first one is 13.5 and 13.5. There is no surplus, neither surplus nor deficit, right? For the next, it will be supply is greater, so 20.25 minus 18.9. Since the surplus is greater, it will be 1.35 in the surplus. And for the demand, here is 10.8, right? Because there is no supply. And here supply is greater, so 13.5 minus 10.8, it will be 2.7 in the surplus part, right? And for here, there is no demand, so there will be surplus of 6.75. Now capacity of reservoir is how can we get the maximum deficit? We need to find that, right? Since there is no any other value in the deficit, this value is the maximum deficit we can get. So our answer will be 10.8 million liter, right? Since we do not have any other deficit, we can say that this 10.8 particular value is the maximum deficit value we can get, right? So this is the thing. Now if we go to the next method, so let's copy this demand and supply. The demand is 13.5, 18.9, 13.5, 18.9, and then 10.8, 10.8 and 0, 10.8, 10.8 and 0, right? Now for the supply part, 13.5, 13.5, and then 20.25, 20.25, 0, 13.5 and 13.5 and 6.75. Let's find the cumulative values. For the first one, it will be 13.5 itself, right? 13.5. The second one, 13.5 plus 18.9, right? It will be 32.4. And for the next one, it will be plus 10.8. It will be 43.2. And again, plus 10.8. It will be 54, right? And here, plus 0 will be only 54. For the next cumulative supply, 13.5 in the first part. And second, it will be 13.5 plus 20.25. Right, 33.75. And again, plus 0 will be 33.75 itself. And 33.75 plus 13.5, right? It will be 47.25. And plus 6.75 in the next. So it will be 54, right? Now let's do cumulative surplus or cumulative deficit. If cumulative supply is more, cumulative supply is more, then we write in cumulative surplus, and if the cumulative demand is more, we write in cumulative deficit. So here, and there is neither surplus nor deficit, right? Here 33.75 and 32.4, cumulative supply is more, right? So we need to write in surplus by subtracting 33.75 and 32.4. So it will be 1.35, right, in the surplus part. And again, another part 43.2 minus 33.75, right? Since the cumulative demand is more, we will subtract this and write in deficit. So it will be 9.45. And for this part, 54 and 47.25, 54 minus 47.25, it will be 6.75, right? And 6.75 in the demand part, right? So deficit part 6.75, right? So here is nothing, and for the last part it will be nothing, right? Now, if you see here, the cumulative capacity equals to maximum cumulative surplus plus maximum cumulative deficit, right, minus total supply plus total demand. So we may not also write this because total supply and total demand is equal, right? So in this case, we may eliminate this value, this particular formula. So we are only adding these two. Maximum cumulative supply is 1.35, right? Surplus is 1.35, and maximum cumulative deficit is 9.45. If we add up this, it will be 1.35 plus 9.45. It will be 10.8, right? 10.8 million liter. So in the previous method, we got 10.8 million liter, and here also we get 10.8 million liter. Now, since the capacity is obtained, we need to add this particular 1% fire demand as well, right? So the final value will be final capacity will be 10.8 million liter as obtained before, plus 1% of what? 54 mld, right? Million liter, right? Here, 1% of total demand. So we can say that the capacity should be 10.8 plus 0.54, right? 1% of 54 million liter. So it will be 10.8 plus 0.54, right? It will be 11.34 million liter, right? So reservoir capacity will be 11.34 million liter. So that's it. Thank you for watching.